66 million years ago, the giant reptiles that had dominated Earth for over 150 million years suddenly vanished. For a long time, the cause of their extinction was purely guesswork, but today, geology and paleontology have reconstructed the sequence of events that brought the age of reptiles to a violent end. This is an investigation into the physical evidence left behind by the ultimate bad day in Earth's history. In 1980, researchers discovered a global layer of iridium, an element rare on Earth but common in space rocks, settled in rocks dating exactly to the extinction event. 10 years later, they found the source, the Chicxulub crater, buried under the Yucatan Peninsula in Mexico. It marks the spot where an asteroid roughly 6 miles across slammed into the Earth. The rock hit the atmosphere at 40,000 miles per hour. The energy released by the strike was equivalent to billions of atomic bombs. Anything within hundreds of miles was vaporized instantly. The impact triggered mega tsunamis that scoured the coastlines of the Americas, while burning debris rained back down, igniting global wildfires. However, localized destruction on one continent cannot account for a global mass extinction. To find the real killer, we have to look at the environment that was already failing. The global ecosystem was already in crisis thousands of years before the asteroid arrived. In what is now modern-day India, the Earth was tearing itself open at the Deccan Traps. For tens of thousands of years, monumental volcanic eruptions had been flooding the region with lava. These eruptions pumped colossal amounts of carbon dioxide and sulfur dioxide into the atmosphere. This caused extreme swings in global temperatures and highly acidic oceans, severely stressing the global food chain long before the final blow fell. The asteroid didn't strike a healthy world. It hit an ecosystem that was already on the brink of collapse. The specific geography of the impact site turned a localized disaster into a global one. The asteroid hit a region exceptionally rich in sulfur. The blast vaporized this rock, injecting millions of tons of sulfur aerosols and pulverized dust high into the stratosphere. This atmospheric shield blocked out the sun for months, or perhaps even years. Global temperatures plummeted, creating a sudden impact winter. Without sunlight, plants and phytoplankton could not photosynthesize and quickly died off. Without plants, the massive herbivorous dinosaurs starved. This meant that giant carnivorous dinosaurs like the Tyrannosaurus rex, which required massive amounts of calories, had nothing left to eat. The dinosaurs were not wiped out by the initial explosion. They were killed by the cold and the total collapse of the global food chain. But the non-avian dinosaurs are the only group that truly vanished. Biologically, the lineage did not actually go completely extinct. The survivors were the theropod dinosaurs that we now refer to as birds. This Archaeopteryx fossil shows the connection. Modern birds are not just relatives of dinosaurs. Taxonomically, they are the same group as the velociraptor. You can see the feathered wings integrated with the bony dinosaur skeleton. These early birds survived the impact winter because their small size required very little food. They had beaks designed to crack open seeds and nuts that had been buried in the soil, which remained viable even during the darkness. Furthermore, their ability to fly allowed them to seek out the few remaining patches of unpolluted water. In a world where the giant reptiles could not adapt to the cold and the dark, these small, versatile survivors inherited the planet. The extinction of the dinosaurs removed the dominant competitors from every major ecosystem on Earth. This vacuum allowed small mammals to move into the light, eventually diversifying into the millions of species we see today, including humans. Subscribe to Ancient World Unveiled for more forgotten truths.